Hello, and welcome to this lesson on the electronic structure of atoms. Our lesson objectives today are as follows. First, we will understand the electronic structure of atoms, including the arrangement of electrons in energy levels. And second, we will understand how to represent the electronic structure using numerical notation. So far, you are familiar with the nuclear model of the atom, which describes atoms as consisting of a central nucleus containing protons and neutrons with electrons surrounding the nucleus. Building on this foundation, today's lesson will explore how these electrons are arranged in specific energy levels, or shells, around the nucleus. By learning to represent this arrangement using numerical notation, we will advance our understanding of atomic structure. This is essential for grasping more complex chemical concepts such as bonding, reactions, and the properties of elements. Let's delve into the electronic structure of atoms by understanding how electrons are arranged in energy levels, or shells, around the nucleus of an atom. Electrons in an atom occupy specific energy levels, or shells, which correspond to areas of space around the nucleus. These energy levels can be visualized like concentric circles around the nucleus, starting from the closest and lowest energy level and moving outward. The first energy level is closest to the nucleus and has the lowest energy, so it is filled first. After the first level is full, electrons start to fill the next level sequentially. An important part of the GCSE course is learning the capacity of each energy level. Not all energy levels can hold the same number of electrons. Each level follows a specific rule. The first energy level can hold a maximum of 2 electrons. The second energy level can hold up to 8 electrons. For this GCSE course, a simplified model is used that suggests that the third shell can hold 8 electrons. For the first 20 elements, once the third shell has 8 electrons, the fourth shell begins to fill. After that, the rules get a bit more complicated. But luckily, we don't need to worry about that for this course. You only need to be able to work out the electron configuration for the first 20 elements for GCSE. So, that gives us the following rules for the first 3 shells when we are considering the simplified model and the first 20 elements. Remember, when these shells are full, the fourth shell will start getting filled. We can represent this arrangement of electrons in an atom using numerical notation. This notation consists of a series of numbers that indicate the number of electrons in each shell, starting from the innermost shell and moving outward. Let's look at some examples to see how this works. Consider carbon, which has 6 electrons. The first shell holds 2 electrons. The remaining 4 electrons go into the second shell. Therefore, the electronic structure of carbon can be represented as 2, 4. Let's apply this to another example, neon, which has 10 electrons. The first shell will hold 2 electrons. The next 8 electrons will fill the second shell. Thus, the electronic structure of neon is 2, 8. By understanding the concept of energy levels and the rules for their electron capacity, we can determine the electronic structure of any element. This not only helps in visualizing the arrangement of electrons, but also in predicting an element's chemical properties and reactivity. Let's apply our understanding of electronic structure to some GCSE level questions. Our first question is, what is the electronic structure of a sodium atom, atomic number 11? Pause this video here and see if you can answer it. The atomic number of sodium is 11, which means it has 11 protons and in a neutral atom, 11 electrons. So we place the first 2 electrons in the first shell. We can draw them on our diagram as crosses like this. The next 8 electrons go into the second shell. The remaining 1 electron goes into the third shell. So the electronic structure of sodium is 2, 8, 1. Now for question 2. What is the electronic structure of a magnesium atom, atomic number 12? The atomic number of magnesium is 12, which means it has 12 protons and 12 electrons in a neutral atom. Therefore, we place the first 2 electrons in the first shell. The next 8 electrons go into the second shell. and the remaining 2 electrons go into the third shell. So the electronic structure of magnesium is 2-8-2. Now, for our final practice question, what is the electronic structure of a chlorine atom, atomic number 17? The atomic number of chlorine is 17, meaning it has 17 protons and 17 electrons in a neutral atom. Therefore, we place the first 2 electrons in the first shell. The next 8 electrons go into the second shell, and the remaining 7 electrons go into the third shell. So the electronic structure of chlorine is 2-8-7. By following these steps and using the atomic number to determine the number of electrons, we can easily find the electronic structure of any element. Well done! Now, let's look at some of the history behind this lesson as an extension task. Did you know that our modern understanding of electronic structure began with Niels Bohr in 1913? Bohr, a Danish physicist, proposed that electrons surround the nucleus in specific energy levels, similar to how planets orbit the Sun. Let's consider this visually to understand what he meant. On the left of the screen is the Earth orbiting the Sun. On the right-hand side are electrons surrounding the nucleus. Can you see how they are similar? Bohr's finding was revolutionary because it explained why atoms emit light in specific colors or wavelengths. His model showed that when electrons move between these energy levels, they release or absorb energy in the form of light. This discovery was crucial in advancing our understanding of atomic behavior and laid the groundwork for quantum mechanics, which is a fascinating area of study. In today's lesson, we delved into the electronic structure of atoms. For your GCSE course, you only need to know the electronic structure up to calcium, which is the 20th element in the periodic table. We learned that electrons occupy energy levels in a specific order, starting from the lowest energy level closest to the nucleus and moving outward. Each energy level can hold a certain maximum number of electrons. The first level can hold up to 2 electrons, the second up to 8, the third up to 8, and if 1 or 2 are remaining, they are placed in the fourth. We also covered how to represent the electronic structure using numerical notation. This notation helps to quickly identify the arrangement of electrons and predict the chemical behavior of the element.